Hello and welcome to another episode of Nutanix Weekly, one of the many XenTegra podcasts with context. This is Phil Sellers, your host again for this episode, and I want to say welcome and thanks for spending a little time with us. We know you probably have very little free time, so while you're on a jog or treadmill or whatever it is that you're doing listening to us, we appreciate you spending a little time with us. Um, we call these things podcasts with context because we try to bring the real world experience and the real world conversations we're having with customers to the conversation here that you're listening to. And as always, the only way I can do that is with other great technologists and minds on the phone with us today. I've got Mr. Harvey Green, CEO of XenTegra Gov. Harvey, how's the world treating you?
Pretty good. Pretty good. I can't believe that you would imply that people are doing other things while they listen to our podcast, though.
Hey, we're all multitaskers in this world, right? We're making waves not a minute.
Yeah, all right. I guess that's true.
Yeah, are you implying our user base is not like sitting in like the 70s like hi-fi headphones and like the rack mount amp, sitting there on a beanbag just totally meditating on just our only our spoken words?
I mean,
Well,
isn't that the way?
I've heard my voice, so yeah. I mean, just I'm not thinking I've got the ASMR thing going on. So I'm just appreciative somebody's listening at the end of the day. But yeah, I mean, other than self-deprecating humor, we're also joined with Jirah Cox from Nutanix.
I'd bring that too. That's fine. I'm a team player. But no, grateful to be a part of the XPU, the XenTegra podcast universe. It's great to be here.
Well, Jirah, we always
Wow.
appreciate you joining us. And bringing the knowledge at the end of the day. That's one of the things I really, really have enjoyed. It's been over 18 months I've been here at XenTegra, and I want to say I got to meet you week one because I think week one I was on a Nutanix podcast with you.
You sure were. I made sure of it.
And honestly, I mean, it's great. Learned so much, and I think everybody listening has learned so much. So just really appreciate you what you bring to the table. Um, and speaking of today, we want to talk a little bit about NVIDIA on Nutanix. And so bringing to the table, we've got a great blog post from the Nutanix.dev blog for everybody watching on YouTube replays. You can see it on screen. But the title of the blog is Running NVIDIA Triton Interface Server on Nutanix. And this was written by Laura Giordano, Technical Marketing Engineering Director at Nutanix. So shout out to Laura. Thanks so much for posting this and giving us something to talk about today.
Laura's fantastic. One of the first SEs at Nutanix, and then now a huge player in tech marketing for us. And if you've been to a .next conference or one of the bigger .next on tours, you've actually probably seen Laura in person. Usually, running some awesome demos right there from stage of something that like just gets announced, and like 2 minutes later, you see Laura giving a demo of it. It's awesome.
That's awesome. Shout out to Laura. Thanks so much for giving us fun stuff to talk about. I mean, this is big news for Nutanix and across the space, right? Doing AI type things on prem. This was a huge topic as we were out at Nutanix.next a few months ago in Barcelona. I mean, as you guys have thought about this, I mean, what are the use cases or what are the things you've had conversations following up of on-prem AI?
Oh, wait, I mean, huge and pretty lengthy, right? But of course, some of the top ones. I even have customers that already are running things like on-prem Copilot, right, to help their software developers write code faster and better, but of course fully privately and of course with performance. Any kind of stuff like inference, image detection, computer vision, chatbots, of course. We've actually launched a number of them even internally here at Nutanix, right, that we're sort of cutting our teeth on around, help query knowledge bases, get answers faster, help support customer service kind of outcomes. So yeah, it's the list is almost limited only by your imagination of what it could help you do, right? Usually there's more questions around how do I start doing it?
Yeah. Yeah. Harvey, you and I know spent some time doing hands-on labs trying to understand how do you do that? I mean, what kind of stands out to you as customers start to have those conversations and the how do you do it?
Yeah, I mean, I think that there's a lot of talk about this overall. And then when you get past the overall talk and we start talking about should we do it and get past that into now, how do we do it? The picture gets deeper and deeper each time, but this covers one of those top level decisions of are we going to do this internally and keep our data here or externally and use something that's already fabricated in there. This gives you the option to do that internally, keep your data where it is, maintain the chain of custody over that so it's not going anywhere. And I'm sure that makes security people just a little bit happier in some cases.
But I think, tailing on to what you just said, there's certain data use cases where we could never, that data was never leaving our data center. So we couldn't tap in.
100%.
We couldn't tap into that and we couldn't do things on that. So that definitely opens new use cases in and of itself.
Yeah, I mean, one of the use cases you've already brought up is being able to go through that internally and be able to help the developers write better code. That in and of itself, you've got developers developing against something that is not out there, not not out to users, not generally available. That you're still doing testing on. That I mean, definitely has some business intelligence in there. Some of the intellectual property that you want to keep safe while you're still in the process of actually making it something.
Yeah.
And keeping that in-house is very important.
I 100% agree. So tactically, one of the ways that we can do this now is tapping into the NVIDIA GPUs in cluster. You and I both worked on some Kubernetes, or I guess it was technically a mini K8 cluster, just a kind of a small scale, doing labs during .next. And so a lot of this stuff is written in cloud native. It's already released as containerized workloads. So you've got to have a basis in that, and then, or not necessarily. In this case, the article we're talking about is creating a GPU enabled VM. But then basically you take some open source projects or some commercial software and you bring that all together. So let's kind of talk a little bit through this one, and it's very I'm going to say cut and dry. It's a step-by-step build process for running the NVIDIA Inference server, the Triton Inference server on-prem. But I guess the introduction walks us through a couple of things, key announcements, things like that. Jirah, do you want to kind of set the stage for us?
Totally right. So this is going to be, to your point, Philip, like a very prescriptive walkthrough. Like you do this, do this, do this, and then at the end of the cooking show, you're going to have a similar kind of a roast turkey. In this case, a Triton Inference server. What this brings together, right, is of course the awesome platform, right? How do I deploy VMs as an automated service? A substrate that I need, like a GPU, like you mentioned. Of course, being NVIDIA certified, great ingredient for a wonderful recipe there. So having Nutanix nodes that are on the NVIDIA certified systems list. And of course, lastly, something to do, right? So this is going to show deploying Hugging Face, who actually more recently than this article, right, as like we all learned together in Barcelona, new Nutanix technology partner, right? So you can now totally get wonderful all the way joint support from Nutanix and Hugging Face for deploying things like this. And of course, the last thing to probably say that just being a good corporate citizen, this is, of course, one way to deploy AI models onto Nutanix. We actually announced at our .next show, right, coming soon, that Nutanix GPT in a box will be an even easier, like more of a product than a process, right? Click, click, next, next, finish. Now you're running AI in production style of outcome. This is more of a let's pop the hood, let's do it from the CLI and get that all kind of running in a bit more of a manual, controllable fashion as well.
Yeah, and I think that's important. Like GPT in a box came out over a year ago, version 1. GPT in a box version 2 was announced during .next, moving it more from a project to product and helping users adopt it easily with workflows and engines to get value out of it more quickly. And Hugging Face, as you said, it's a community with all of the tools and things to help you with your AI development. So it's bringing that side of the equation, the development, the software side of it to what we need. So probably not going to need to go into depth as we go through this, but I mean,
yeah, principles will still apply.
Yeah, principles. First step up, we're going to create a GPU enabled VM. Obviously, you've got to be able to consume the GPU cycles, so that makes a lot of sense. But
I think two neat takeaways here with the way Laura does this, that, especially if you're coming to Nutanix and you have more of, like what I used to have, a very traditional Windows Server admin background, a couple of really cool technologies here. One is that a lot of your Linux vendors, in this case, we're going to show using Ubuntu in the late LTS there, 2204, the Linux vendors will give you, here's a full-on bootable virtual disk image. It's not an ISO for installation. It's a virtual hard drive. You can just power it on, right? Just download it, turn it on. One of the most rapid ways to get a workload up and running, right? Just download a Linux image. Second one, though, is showing the cloud init file, which is a way to, as you're creating the VM, paste in a little block of text that says, essentially like an on first boot, personalize the VM this way. So in this case, Laura's doing that to turn on SSH, so the VM can then be accessed over SSH via PuTTY or the Windows command line or Mac command line. And secondly, set a password for that. So now we can do that securely as well. So some really neat tricks to take away here from just a general sysadmin point of view of ways to get Linux up and running on Nutanix rapidly, whether we do a GPU or not, whether we're doing AI or not.
Yeah, absolutely. The key here is that pass through. That's what we're tapping into in the virtual machine. But the guest
so step 0, have a GPU. Step 1, pass it through.
Yeah. Yeah, and then again, like you're pointing out, cloud init, the scripting language to just onboard that, make it easier to do this in mass, right? I mean, automation has always been a core component of Nutanix. Being able to pass that through onto the software layers is now a critical success factor as you try to do projects like AI inference engines on the infrastructure. So just following through that same thread of heavy, I'm going to say heavy, but I don't mean heavy in a bad way. I mean heavy in a good way, very orchestrated workflows.
Yeah, that's a good point. Like thinking about like zooming in from like the house to like a brick, like this could be a workflow where like my VM creation automation might randomly generate that password and stash it in a vault or an ITSM versus, in this case, use it as hard coded, right? But it shows where you could stick that variable in and use this for a more repeatable, more broad, more secure automated process.
Yeah. Yeah, it looks like in this example, there's still some manual stuff that we have to do. Once the VM's created and up and going, we have to install some drivers. It has to know how to talk to the NVIDIA GPU at the end of the day. So what else are we doing here? It looks like we install some drivers, and then what's next?
We're installing drivers, verifying the output of that. Oh, of course, installing Docker, right? Want to have a way to run containerized applications. So installing Docker, installing the NVIDIA Container Toolkit. This shows that coming out of the NVIDIA GitHub repo there.
And that's something that stands out to me. Like, we're going after repos and pulling this stuff. We're not writing this stuff, but we're just tapping in and pulling it down. We're consuming it at the end of the day.
Yeah, totally true. The installing Miniconda, small, which I just checked out their repo as well to see what that is. Miniconda is a free minimal installer for Conda, which is a bootstrap version of Anaconda that includes Conda, Python, other things like that, pip, zlib, and a few others. So application kind of framework runtime to get Python up and running in a kind of predictable state there.
Okay.
So installing Miniconda.
What's Miniconda? So
yeah.
You know, as an infrastructure professional coming into this, there's so many different tools, libraries, things like that. Just understanding all the different components that we're tapping into is sometimes a difficulty as you approach these projects. But I think that's where a quick start like this definitely helps us to see it and then start to build on what we've successfully done to do the next thing.
Totally. In some ways, I think, standing up AI or GPT or LLM based solutions in a data center are maybe the most hardware defined thing that some of us have done in 20 years, right? We've been doing things in VMs, right? Things where it's just like define your resources in an abstract way of CPU memory storage. And this is kind of getting back more very close to the metal of like, no, thou shalt have this GPU, which needs this driver to talk to it, and here's how you stand that up, kind of stuff. Much more prescriptive than what some of us are very used to for our day jobs. So getting that the Triton Inference service stood up itself again. Here again, we see that pulls down from GitHub. The Inference server is, of course, like NVIDIA's packaged way of running this sort of as a larger like framework of like how can I run models and GPTs and LLMs in my data center. I could run tens of thousands of them, and then I could do training. I could run one or two or three, and then I could do inference or run an app or do a proof of concept. So this, of course, is going to be a single node, but there's no reason this couldn't be scalable as well. So pretty simple there, git clone, and then run a script that it provides there locally there.
Yeah.
And then, of course, we launch it as a Docker run, right? So here we see that Docker framework standing up the containerized microservice that it provides there to run the Triton server and expose that on a web server.
Yeah, and so I think it's important, as we talk about this, we're looking at Docker. This is a proof of concept. This is not a production scale thing. Likely the same container would run on a Kubernetes infrastructure at scale with other things configured. This is more of a POC type proving ground where you can easily get things up and running, but this is a single instance sort of thing, not something that's ready for production. So we've got a Docker container up. Then we send an inference request. What is that?
The inference request, I'm catching up with you here as well, is actually passing it. Looks like a JPEG here that's asking it to infer, right? Spoiler, inference server infers what's in this picture I just gave you, right? And what's really neat is, so of course this is to your point, Philip, very, very proof of concept ish, very kind of not quite rudimentary, but very low level, right? I give it an image, I get back text about what's in the image, right? And like confidence scores, I think that's what the numbers there imply. Coffee mug, cup, coffee pot, right? What was in what I just gave you? So image classification type activities here.
So I'm scrolling back up a little bit. So like that seems like magic to me, right? I've just pulled a couple things from GitHub. I've said a spell and suddenly it's giving me this text that says it's coffee cup. But that's not actually what's going on. Above when we launched this, and I think we may have skipped over this, but we fetched a model. And I think that's an important concept for people to talk about when we talk about AI, is that there's a model that we pulled as well. That model was trained somewhere else. That model is being consumed, but we're benefiting from the knowledge of that model that training happened somewhere else. And so it's not black magic. Somebody spent a lot of CPU cycles creating that model that we're now consuming.
Yeah,
Totally.
I kind of liken this to encyclopedias. only because I tell people all the time my kids will never know what it's like to pull an encyclopedia off the shelf and
Right.
have to look something up. This is like bringing in the encyclopedia and basically teaching what you needed to know in order to accomplish the things that you're planning on doing in the near future.
Yeah.
Totally. Yeah, fully agree with you, Harvey. Like if you're listening to
May have
this,
dated myself there.
no. The fun version that I'm doing with my kids lately, they're 8 and 11, is like if we're driving along, I'll point to like a telephone pole and go, kids, what do you think that is? And why does it exist? And what does it do? Right? Like it is just not part of their life in any degree whatsoever.
Right.
And not to completely take us down a rabbit hole, but we call them telephone poles, but they run electric wires. They don't run telephone wires for the most part anymore, right? I mean, anyway, that's a complete. They're both looking at me.
I wouldn't say that. Yeah, they're definitely not used very much. But no, you're right, Harvey. If you're listening to this, like the vast majority of customers, like if you are a customer who, as part of running IT, you consume power, you don't generate power. You're probably going to consume AI models. You're not going to train AI models, right? Same kind of thing. It is done elsewhere, and you get the benefit of it within your four walls.
Yeah.
So people talk about the energy consumption of AI, right? That's not what this is. That's the other thing. That's the training. That's where these models take enormous amounts of power and processing to be created.
And maybe literally dozens of thousands of GPUs all working in parallel for weeks or months on end to do that training activity.
Yeah, and I think that's a really important call out because it's not just happening in the box, but there are things certainly happening in the box that we're talking about. It's just not training the model. So then we close this out, this example of the coffee cup, and then we move on to another example, loading a Hugging Face model in Triton. So now we're going to use another model loaded into the Triton engine. What comes next?
Yeah, so now that we've sort of tested, like we have proof of life, right? We've done like a hello world, like that's neat. I can do that one time as a command line, standing it up. What can I do that's more business useful? So this shows deploying Hugging Face itself as a model into Triton, right? So there's going to be one thing now that the Triton Inference Server like vends to the business or for our dev teams to go consume. So then we have the text block here that via Python stands up and deploys Hugging Face into, this is of course using that conda that we'd previously installed there. That ultimately gives me a Python-based pipeline that I can then use for, this is showing an example where it actually does it via text, right? So like give me some text generation here, where if I provide it with like an AI, usually the word is prompt of my favorite food is, and just let it riff, right? What does it think? Like let it take a guess with zero data whatsoever what your favorite food is. And we see here the sample return is like iced coffee and chocolate, which actually so far we're pretty accurate. This all sounds amazing. And almond sugar. I mean, yeah, that's pretty neat. So this one is showing a text-based use case of when I pass it a prompt, finish the prompt for me, right? So you can picture that working with KB articles or user-provided questions or answers, or what's the way to configure this or whatever. What's our SOP for a given activity? All that kind of stuff. So then beyond that, this is showing ways to store multiple models, right? Like Hugging Face, like others, elsewhere for the inference engine to then go consume, right? So this is where we've said it before on the podcast, but worth reiterating. When you run things in, say, like a containerized environment, the containers themselves are, of course, fully immutable and don't store data within them. So you'd be putting data that you want to infer on or storing models somewhere else in some other directory, right? You can do it locally on the VM. You can do it on a NAS, NFS, SMB. You can do it on, You could do it on object storage. You could do it on block storage. Lots of ways you could solve for that. So this is showing other ways I can configure a repository and how do I set up my directory structure there and my indexing and naming or nomenclature to get that aligned the way that the application expects. And then finally, our model code, right, to say how do I run different models there within the inference engine. Talks about importing required libraries, right, around Triton Python backend utils, of course, required for every Triton Python model. Calls out NumPy, specific Python library there that does multidimensional array computing, and then transformers. That's the library that provides Hugging Face, and also supports downloading and training models itself. Right, transformers is like one form of an LLM, usually text based. I think, from my understanding.
Mm-hmm. A lot of the code that we're looking at on screen, and I know that folks listening can't really see this, but
I'll read it to them.
I was going to say
Harvey's paid on episode length.
Yeah, it's pretty human readable, though. I mean,
it is.
It's approachable.
Yes.
And yes.
And ultimately what this is translating is what we did before was like a single Linux command line of like, look at this JPEG, tell me what's in it, and it's coffee cup and whatnot. Let's evolve that into what can I consume, securely over, say, like a web call, right, or an API call. More scalable for the enterprise, right? Doesn't need to be at the command line of the Linux VM, but ultimately kind of same output, right? I want to pass an input to an LLM and get the response back out of it.
And as a consumer, so IT professionals, infrastructure professionals, we all consume applications all day long, whether it's SaaS for our, time cards, or our payroll, or ServiceNow for our IT tickets and things like that. We're all consumers. So what actually is being done here, to Jirah's point, is more of a API call type thing. A lot of these engines and services, they're exposed as API calls so that other services can interact with them. And I think that's another important thing is the power of this is underneath the covers, but there has to be that interface, and it's not going to be just a generic web page like we're accustomed to coming to, to interact and do things. That may then talk to this on the back end, but a lot of these models then get used and consumed through other web services through the API. So yeah, I mean, all this stuff sounds neat, and I think we may incorrectly think that this is Chat GPT and there's going to be a nice web interface and we type in a box and off we go. That's just one way of interacting with this, and more than likely in the enterprise it'll use an API from other places to actually talk to what we're doing with these inference servers and services that we deploy in the enterprise.
Yes, like
I
anything
can picture
else in IT, there's a command line option and there's a GUI option.
Right. Yeah, I can picture for most of our customers, right, if we walked in with this tomorrow, the first question we'd get is, can you make this connect to Teams or Slack or whatnot? So, not a web server, but like put it in the applications that I'm already using. So that kind of connectivity, right, is kind of usually that last mile dial tone, if you will.
And I think that's the key takeaway. We have to think about not only what happens in the processing, but how do we interface with these kind of services moving forward. And I think you hit the nail on the head. We want to consume it where we already are, because I need another channel to check, like a hole in my head. I've already got Teams and Slack and email and text messages and everything else. We just want to consume it where we already are. So this is a great model, and a great example. This is inference focused. This is GPT. It's that generative AI sort of stuff. Through the examples we've looked at, it's taking image data or things like that, helping us understand it, pull context out of these data sets. What are taking something like this, what would be the next step to to take it out of proof of concept and move forward for the enterprise?
I would say, having kind of read through the blog post as we've described it to our audio only listeners, this one's one that's worth clicking through into, right? Find this article on, running NVIDIA Triton Inference Server on Nutanix. It should be the first Google hit for that. But when you do this, like, this is actually really accessible. It's easy to get up and running in a lab environment, in a home lab environment. You're looking at less than 150-ish lines of text, maybe under 100, all of which, thoroughly copy pastable, so easy to grasp. Really good way to cut your teeth on this. Beyond that, I think for most IT professionals, it's partnering with the business, right, to understand, like, where are we looking to use this? Where do we want to consume, fully GPT LLMs in the cloud where there's not sensitive data in play? Where do we need to have a strategy around private performant AI that lives only behind our firewall, where we do want to have it touching things for data we don't want leaving our four walls?
Yeah. And then, is it consumable, or do we need to partner with a third party? I would add that one to it. So there's lots of different technologies and ISV softwares out there. So if you're trying to do something with video, maybe, safety is your core use case there, and you're trying to spot bad things in video feeds. An inferencing engine like this could be a big part, play a huge role in that, but it may need layers of software developed on top of it to be able to do what you're looking to solve for. So the third-party market is probably a big component in a lot of the use cases too. Closing thoughts, guys? I mean, this is interesting. It's cool to geek out and kind of talk through this. It's really cool that we have the capability. I think that's more than anything for me. What's your key takeaways?
Yeah, I think it's really neat how democratizing the technology is, right? Like, never before have you been able to do so much with kind of like so little. Like, I just have an old GPU laying around. I can go play with this tomorrow.
Yeah, and I think being able to have a model like this that's approachable on a platform you're already using, just something you can go in for the audio only people. They at least have to come in here and look at some code, since Phil and Jirah wouldn't let me read it. But it's very approachable. It's something that you can do and actually see the end of it, within a very short period of time. Like Phil talked about, we did it, in a hands-on lab. So, you can see the end and see the results at the end of it within a day in some cases. So you definitely have the power and the ability to get something like this going internally. Take a look at it and I don't know, just put on your hugging face.
Right. That's a great way to bring it back around. And now for all of our sleep challenge listeners, we are going to take to the next section of our podcast episode, and Harvey's going to read you code. So
cheaper than medication. That's our tagline.
I'm going to need you to help me with some of these words I can't pronounce.
Well, guys, as always, appreciate you guys joining us, talking through capabilities in the Nutanix platform. And, at the end of the day, it is a platform, right? All of these capabilities, all in the same style of operating, heavily orchestrated, heavily workflowed, all of the goodness that we talk about from Nutanix. Jirah, Harvey, thanks so much for spending some time with us.
Absolutely.
Thank y'all.
And for everybody listening, hopefully you will join us back again very soon for another episode. And in the meantime, we'll see you on that next episode.